Hi my friends, today we create and animate this symmetrical joint, which is very interesting. This is the assembly and you can see how it looks. Let's start with creating the assembly. New standard millimeters IAM, place the plate. I place it grounded at origin and you see that it is placed position of Inventor 2014. You receive components made with this version of Inventor because I want you to use them no matter what version you have. So I rotate this, I select the corner. You are familiar now with this, and I apply set current view as home, fit to view. Now I use home to place in position this first component. We continue with placing bearings, which are 3. 1, 2, 3. Then we place them on the plate. The first, apply. The second, apply. And the last, apply. Good. I select one of them, this one, which is bearing number 2, and I make visible the 3 planes which are definition for this object. You know that this is absolutely identical with the other 2. So when I make this visible, we see that planes on all the 3 components. Another group of 3 planes has also the plate visibility. Why I do this? Because I want to constrain this plane with mate directly not aligned with this plane. Apply. You see, this object can be moved only along this plane. This component, which is this, has a center point. This is its center point. I select it when I want to use it for constraining. Constrain, you see this was selected and it is visible, and all I have to do is to select where to be placed this center point. I want to be placed on this plane. Okay? You see now how are their position. Apply. I collapse all the components and I add another one which is not the shaft, not this one, but central shaft. Open. This object has its center point, which is placed in the middle. Center point, make visible. It is inside. This is why we don't see all the time, but we know that it is there. I apply constraint with simple mate. Apply. Then I place the center point on the plane of this bearing. This is bearing number 2, and the plane I want to use is this one. Okay, what we have here? We have a not movable component, this bearing, and this is movable, but not along, not up, not down, but rotate is possible. We don't use this plane. Good. I make this not visible, and we go on. We go on with placing the 2 levers. Double click, 1, 2, and we use the constraint insert to place this. It is very symmetrical, and I can select this one to be placed here. Apply. Then I place the other one right here. Okay, now these 2 are movable independently. I want to be placed forced together. I suppose you saw that we don't have here a keyway or a shaft with the keyway, so this is strange for a mechanical engineer. We are mechanical engineers, but in Inventor this is very, very possible. What is very possible? It's very possible to select angle, this solution, and to place at 0 degrees this and this. Okay, their behavior is just like having keyways to both. Good. I hope you see this point. You see this one and also this one. Why are these points present here? Because we need them. This is why. If you open here, you see work point placed at an intersection, something made in creation of this object called lever. You'll see what is this for. Now I add new components. the shaft. 1, 2. I place them in position by using insert. I select this and I place here. Apply. Then I select this to be placed here. Apply. Now I make something interesting. I place the mid plane of this bearing as well as the other on this point. Oh, interesting. This is the third bearing. If I don't know this, I select it, yes, and I see here the selection. I apply constraint for the third bearing. Its plane YZ to be coincident with this point from the lever. Okay, now we can move this only along this plane and containing this point. The same for the other one. You see, there is a point also here. I use this bearing, which is the first one. I apply constraint for the first bearing. The plane is this one, and the point is this one. Okay. Again, I can move this as I want. Very good. I close this and I add the forks. 1, 2. Constraint, insert this circle to be here. Apply this circle to be here. Apply. Then I force this face to be at an angle of 0 with this face. Angle, first solution, 0 degrees, this with this. You see, they are aligned. Apply also here. This face with this face. Apply. Now what we have here? We have a free movement along this, but if I rotate this, you see we have rotation also to both shafts. To be place them in the final position, we use this point. Constraint with mate and first solution of this axis with this point. You see? Apply. this axis with this point. Okay. Now I finished the problem. What I don't like is the light. Let's change the light. We use this tool, view, not default lights, but two lights. You see, it looks in another presentation. I move this to the right to make room for this. Settings. And now I have two lights, light 1, light 2. Both are active, the other ones are not active. I can activate all the four to create something like at a movie. This has the color gray. I don't want the color gray. Take a look here. I select this and now okay, the light was changed. Yes, then I go to the first and I move the horizontal position in another value, for instance -11. Also this on vertical, and I select -56. The other light is here 43 and this is good, 39. Now take a look. It looks better, yes? I want you to keep in your mind two things. There is no any connection between these two objects. A hole like this one and a small pin to be placed here. Even if we can use it, nothing changes. And the second is that we have seen this hole. You can place a hole here with a pin to make sure this too, and not using glue to place to fix the position between axis and object. Also here. Okay, now I make something for applying rotation. I impose a constraint of angle 0 degrees, first solution, between this face and this face. Okay, what is this? Is the lever 1. I find here an angle with this 0. This is the angle, and you see what faces are implied in this combination. Drive, and I place here 360 because I want to see how it works, how the join works. Start. You you see that nice movement, rotation. Go back. Okay. Now I want you to see something else. This is placed at an angle. Yes? Which is this? This is the bearing. Angle is this one. I change the value. Minus 120, for instance. And I have this new position. I wonder if it works. No, it doesn't. They are one inside the other. This is not good. Double click. I apply minus 150. Now it's better. Yes? More than this, I can change it to 160. When I apply, you see the new position. This is different as an angle than this. We go back to drive. Drive was applied to this. Angle, drive, and go. It works. You see? You can rotate these two bearings as you want, but without collision, of course. Okay. Now comes an interesting topic. What I present here is based on the existence of the components that appear in the assembly. Regarding this modeling, you have two options. One, to contemplate what I do and apply my actions by creating your own components of this assembly. And two, try to create the assembly using the actual components you see in the tutorial. If you want to create this assembly independently, you must own the component. That is, they must be yours. As separate creations that I made for the purpose of showing practical aspects in the tutorial, you can download the components only from assets. Access to assets is done by subscribing minimum to the level Journeyman membership. You see here the levels of membership: Core, Journeyman, Patron, Professional. Excepting Core, the other ones include the previous ones. That's all for today. Thanks for watching. Bye bye.